As said before, we need a measure of outlyingness. So the first measure we will take a look at is the leverage of an observation. So for each of the observations, we can calculate a leverage score. The leverage will identify influential predictor observations. So it will look at which points are different from the other points in the predictors, in X values, so not in the output Y. How do we look at leverage? Basically, what leverage does is it takes observation I, one of the observations, it looks at the predictor values for that observation, and then it will compare that to the values of the predictors for all the other observations. So it will see, are the values from observation I very different from the values from the other observations or not? The way to do it is basically through the matrix notation of our optimization problem. So linear regression can be written as an optimization problem. It can be transformed in a matrix notation. And now we get in somewhere in those calculations the hat matrix H. So the hat matrix, or also the projection matrix, or the influence matrix. H is X times X transposed X minus 1 times X transposed. So in this notation, X is a matrix which has P columns and N rows. So it has one column for each of the predictor values. It has one row for each of the observations. Details are not too important, just a little background. So what H does, basically it maps the outcomes on the predictions. So it will be like this, Y hat. My prediction is H times my observations. So Y is then Y1 up to Yn, and this is Y hat 1 up to Y hat n. So H is the one that projects, that transforms my observed values to my predicted values. What is good or bad leverage? Basically, the larger the leverage is, the closer the prediction is to the outcome, and the more that the predictor values will deviate from the mean or from the other values. So a high leverage means that my point will be outlying or very different from the other observations. Very different does not necessarily mean it has a large influence on the regression model. So it possibly has a large influence on the regression model, but that's something that we still have to check. We just know that now it is outlying, it's different in the predictor values in the X direction from the other ones. Next step is to check whether or not it has an influence. Leverage, the average leverage is P over N, with P the number of unknown parameters and N the total number of observations. And then we say leverage is extreme if it is larger than 2P over N. In our case, so the example of the largest, we had N is 26, P is 7, and so the extreme value, or the cutoff value here, this is 2P divided by N, or 14 over 26, which is 0.54. So if we look at this cutoff value, we see there are two points which have a high leverage, observation number 1 and observation number 4. These points are thus differing from the other observations in their X values, in their predictor values. Next step, we have to check, are they influential on the regression model or not? To check whether or not they are influential, we will use Cook's distance. So Cook's distance is a diagnostic measure for the influence of an observation on the predictions. So the leverage looked at the predictors. Is my observation different from the other observations? Cook's distance will see, does my observation have an influence on the model? So if my Cook's distance is large, or well, basically, if my diagnostic measure or my observation has a large influence, my Cook's distance will be large. So I want to see, does it change the predictions? Does it change the regression coefficients very much? So if it changes the predictions, it means that my model is very different from the model without the observation. and so it will have a large influence on the model. So it will change the model, it will attract the model towards itself. So Cook's distance, a diagnostic measure for the influence of the ith observation on our predictions. And how do we calculate it? Basically, we will look at the model with observation I, and we will recreate a model without observation I. So we get model 1 with observation I, model 2. What would be the regression if we leave this observation out? And now we see, are these models very different, yes or no? So are the coefficients, the estimated regression coefficients in model 2 very different from the estimated coefficients in model 1? If they are very different, it means that it has a large influence, and so it's a very influential point. If they are very similar, the influence is very limited. So we just check, so we make a difference between the predictions made by model 1 and the predictions made by model 2. If these are different, it means that the models are different and the regression coefficients are different. So how will we know when it's influential? So we said a large Cook's distance means that there is a big influence. When do we call it large? We will use a distribution for that. So we can show that this di follows an F distribution with p and n minus p degrees of freedom. And so we'll say it is influential if it exceeds the 50% percentile of this distribution. So if we go back to our example, we know n is 26, p is 7, so my F distribution is one with 7 and 21 degrees of freedom. If we then look for the 50% percentile, the value we get is 0.94. So 0.94 means that we compare to this value. And so if we calculate Cook's distances for all these values, we see that only the first one is above the value of 0.94. So the first observation is not only an observation which is outlying in the x direction, but also has a large influence on the model. Whereas the fourth observation, 1, 2, 3, 4, this one, is below the threshold, is below the cutoff value for Cook's distance. So it does, or it is outlying in the values of x, but it has no big influence on our model. Finally, let us take a look at the plot of the model. So when we plot the model, we get 4 residual plots. The first one we used to check linearity. The second one we used to check normality. The third one was used for homoscedasticity. So logically, there is one plot left, which we will be using now. The fourth one, the last one, is used to check outliers and more specifically influential points. So what you see is that you have a leverage in function of the or basically the residuals in function of the leverage. So if you look at the scatter plot, you can see which points have a high leverage. So the high leverages here is this one, which is observation 1, and this one, which is observation 4. Furthermore, also Cook's distance is indicated on the plot. It's not in the same way as we use the values, but Cook's distance here is indicated through the dotted lines. So you have a dotted line which corresponds to 0.5, you have a dotted line which corresponds to 1, and basically these are different cutoff values for Cook's distance, and points which are outside these dotted lines, these are considered to be influential points. So these are considered to be the ones that have a high influence. So also here we see that number 1, observation 1, has a high influence on the regression model.